Welcome back to my channel, and here we are still working on determination of the true length and true inclinations of a given line in space. How to determine the true length and true inclinations of a given line in space. Now, this particular question that we want to solve, we have used it before, and there we use the first method, which is rotation method. Now, we want to use the trapezoid method to determine the true length and true inclinations of this given line in space. Okay, I'm going to read the question twice, then we go on and look at how we can determine the true length and true inclinations of this given line. The question says a straight line PQ has its end P 15 millimeters above the horizontal plane, that is HP, and 60 millimeters in front of the VP, that is the vertical plane. The end Q is 45 millimeters above the horizontal plane and 10 millimeters in front of the vertical plane, that is VP. If the end projectors of the line are 60 millimeters apart, draw its projections, determine the true length and true inclinations of the line with the principal planes. I will take it again. A straight line PQ has its end P 15 millimeters above the HP and 60 millimeters in front of the VP. The end Q is 45 millimeters above the HP and 10 millimeters in front of the VP. If the end projectors of the line are 60 millimeters apart, draw its projections, determine the true length and true inclinations of the line with the principal planes. Alright, that is the question. Now let's go and see what we are to do. So the first thing that we are to do is to draw the XY line. Okay, so draw the horizontal line, that is our XY line. So this is point X on the line and this is point Y on the line. Now the next thing that we are going to do is that we move away a little bit from point X, and then we draw a vertical line like this. Okay, then this point on the line, we call it point O here, and then we take a measurement of 60 millimeters away from point O, as we are told that the end projectors of the line are 60 millimeters apart. So this is 60 millimeters, and then so we are going to draw a vertical line through this point. So through this point, okay, so here we draw a vertical line here like this. Okay, so these lines are the end projectors of the line. So this point, we call it point O prime, okay, as we have here. Now the next thing that we are going to do is to determine, or is to locate point or the end P of the line. But before that, so this is the vertical plane. Okay, so here we have the vertical plane. Okay, then here we have the horizontal plane. So this is the horizontal plane here. So let's take note of that. Okay, now so to determine to locate the end P of the line on both the vertical and the horizontal plane, as we are told that point P is 15 millimeters above the horizontal plane. So we are going to take a measurement of 15 millimeters above the XY line on VP. So this is 15 millimeters, and this point here is point P, so P prime. Then we also told that it is 45, okay, it is what? It's 60 millimeters in front of the vertical plane. So 60 millimeters in front of the vertical plane, we take it down the horizontal or down the XY line on the horizontal plane. So down the XY line on the horizontal plane, this is 60 millimeters, and this is point P here. So we call this point P. Okay, so next we also have that the end Q of the line is 45 millimeters above the horizontal plane. So that 45 millimeters, we take it from this point O prime above the XY line into the vertical plane. So we have this to be 45 millimeters. So this point is point Q here. So call it Q prime. And then we also have that the end Q is also 10 millimeters in front of the vertical plane. So we take 10 millimeters down the XY line or below the XY line and 10 millimeters into the horizontal plane. So we have this. So this is NQ here. Okay. So here we have NQ. All right. So then to draw the projections of the line, so we are going to join these 2 points together. So P prime, Q prime. So we join them together like this. Okay. And then, so here we also join this point P and Q together. So we have it like this. Okay. All right. So this is the front view of the line. And this is the top view or plan of the line. So we have drawn the projections of the line. So but we are going to draw a horizontal line. So we draw a horizontal line through this point, and then we also come here, we draw a horizontal line through this point like this. Okay, we have this. Now the next thing that we are going to do, as we are using the trapezoid method, we are going to draw a line at this point that will be at a right angle to this line. We draw a line at this point that will also be at a right angle to this line. We are going to draw a line at this point that will be at the right angle to this line. We draw a line at this point that will be at the right angle to this line. So that's what we are going to do. To make it simple for ourselves, so what I do is that I put my protractor at this point Q prime here. Okay, so making sure this line is on line PQ as I've set it here. So then we put a dot on this line or at this point 90 here on the protractor. So let's take note of that. And we also come here to point P here. Okay, so we set the protractor at point P, and then we put a dot on 90 as we have it here. So why here now? So the same protractor, so now turn it like this. Okay, so we set like this. Okay, then at point P, so we set like this, and we put a dot on 90 here. So here we have this. Okay, and then so we come to point Q, so setting the protractor here at point Q and the line on line PQ. So then we put a dot on 90 as we have it here. So the next thing that we are going to do is that we are going to draw a line from point Q through this point, and it goes like this. Okay, so we have like this, and then we also draw a line from point P passing through the point, so it goes like this. Okay, and then so do the same thing here. So here we have, so we draw a line from here, so passing through this point we have this, and then we draw a line from point P, so passing through this point, so we have this like this. Okay, all right, so each of these lines is at a right angle to line PQ, and these lines are also at right angle to P prime Q prime as we have it here. So now let's look at the next thing that we have to do. So we want to determine the true length now. Okay, so the first thing that we are going to do is that we are going to take this distance. So starting from here, so here in the horizontal plane, we take this distance of point P from this point O here. We take this distance OP, so like this. Okay, so from point P, so we take it and then we bring it here, put the pinpoint here at point P prime, and make an arc on this line. Okay, so this point here is point P, so we call it P, capital letter P1. So let's call it P1, and then so we now take what? We take this distance Q from O prime, so Q from O prime, so we take it like this. Okay, so here we take this distance from here to here. Okay, so O prime Q, so then we bring it here, and then so we make an arc here like this. So this point is point Q1. Okay, this is Q1. So here we have this now. Then again, so if we join these 2 points together, this will give us the true length of the line in the vertical plane. So joining these 2 points together, this gives us the true length of the line in the vertical plane. So this is the true length of the line in the vertical plane. So we have this now. Now let's work on how we can get the true length of the line here in the horizontal plane. So what we are to do is that we take the distance OP prime like this. Okay, so we take this distance OP prime. Okay, so then we'll bring it here. I'll make an arc here like this. So this point here, this is point P. So this is point P, capital letter P. So we have this. Then we now take again, so this distance O prime Q. So we take this distance O prime Q. So we have this, okay. Then, so we bring it here to point Q here. And then, so we make an arc here like this. So this is point Q. So capital letter Q. And then, so by joining these 2 points together, so we have the true length of the line here in the horizontal plane. So we join this together. So we have the true length of the line here in the horizontal plane. So here we have what? This is the true length here in the horizontal plane. So we have this. So true length of the line here in the horizontal plane. So we have this now. Now, so let's write out the true length. So true length of the line in the vertical plane, so which is equal to P. So P1, Q1, so is equal to, and then so we also have the true length of the line here in the horizontal plane, which is equal to PQ. So PQ, so is equal to, so let's take the measurement. So if I take this measurement, so we have distance from here to here. So this is what? This is around 85 millimeters, okay? So here is what? Here is, so I have to state it. So we have this to be 85, so plus or minus 1, that is the true length. Okay, then we also have it here. So taking this distance from here to here, so this is also around 85. Okay, so I'll also take this as 85, so plus or minus 1. So that is it. So we have determined the true length. Now let's go and look at how we can determine the true inclinations to the horizontal and the vertical planes. Now, so let's get the true inclination first to the vertical plane, true inclination to the vertical plane. So in this method that we are using, which is trapezoid method, so the angle that we are going to get here will be true inclination to the vertical plane. Why? Because for us to get the true length here, we took the distances that we have here in the horizontal plane. Okay, we took the distances that we have here on the horizontal plane for us to get the true length here in the vertical plane. So the angle that we are going to get, or the inclination that we are going to get here, will be true inclination to the vertical plane. So to do that, so what we have to do is to extend this line. So we extend this line, so we extend it like this, and then we also extend this line for them to intersect. Okay, they intersect here. So what we have here, so if I make an arc between these 2 points, okay, or between these 2 lines like this, okay, so this angle that we have here, so true inclination to the, so I'm going to call this angle, I will call it angle alpha here. Okay, so true inclination, so alpha is equal to the true inclination to the vertical plane. So by setting my protractor like this, so I can determine this angle. So setting at this point, I can determine the value of this angle. So looking at this angle that we have here, this angle is around what? Around 35, 36. So 35. So the other method that we use, that is rotation method, we got 36. So 35, 36 is still okay. So there's nothing wrong here. So what I have here, so this is 35 degree. So if I have 35, 36, so they are still within the range. So this is true inclination to the vertical plane. So let's take note of this. So true inclination to the vertical plane, as I said, that this angle will be true inclination to the vertical plane because the distance that we use to determine the true length of this line, we took them from here on the horizontal plane. Let's take note of that. Okay, so now let's get the true inclination to the horizontal plane. So what we have to do is to extend this line. So we extend this line, and then we also extend this line for them to meet. So we extend this line like this. So they intersect at this point. Okay. So this angle here, so this angle that we have here, so I'm going to make an arc in between these two lines like this. So I'm going to call this angle, I will call it angle theta. Okay, so here I'm going to put theta here. So this angle is the true inclination to the horizontal plane. So theta is equal to true inclination to the horizontal plane. So let's get the value of this angle with the use of a protractor. So setting my protractor like this at this point. Okay, so setting like this at this point. So I have this angle to be angle 21 degree. So 21 degree. So this angle is 21 degree. So here I have this angle to be 21 degree. So theta is equal to 21 degree. So 21 degree. And this is what? This is the true inclination to the horizontal plane. True inclination to the horizontal plane. It's as simple as I've done it here. So this is trapezoid method. It's as simple as I've done it here. All you have to do is to practice. When you practice this, you become a master at this work. Thank you. Keep on practicing, and God bless you.